Hello calculus! In this video I'm going to review function composition for the chain rule, and then I'm going to present the chain rule for us at the end and do 3 quick examples. Then I'm going to do another video about just a bunch more examples on the chain rule and some further applications. So to start off, the first thing we're going to do is just do a little bit of review. And I'm going to do this exercise that I've done with other classes and found really useful. So I'm going to define some functions. So let's define the following functions. Let's say that f of x is the function, the exponential function, e to the x. Let's say that g of x is the function x cubed plus x. Let's say that j of x is the function 2x, and let's say that k of x is the function x plus 4. So function composition is a way that I can combine 2 functions into another function. So I'm going to remind you a little bit about what that notation looks like. But first, we're going to do some activities here. So for the first thing I want you to do, I want you to find the following. Functions. I want to do f of k of x. I want you to find g of j of x. I want you to find g of f of x. And I want you to find f of g of x. I'm going to do this first one here as an example in case you don't really know what this means, finding f of k of x. I'm going to do this as an example for you in red, and then I'll give you the chance to pause the video and do these other 3. So I'm saying find f of k of x. So what that means, I'm going to take f of k of x in here. So notice that in the function f of x, whatever my input in here becomes my exponential. So if I were taking, for example, let's just leave this blank, f of something equals e to the whatever that something is. So if I take f of 2, it's e squared. If I take f of 4, it's e to the 4th power. If I take f of a, that's e to the a power. So if I take f of k of x, like we have up here, that equals e raised to the k of x power. And what is the k of x power, right? That's the question that we really should be asking ourselves, is what does that mean? What does it mean to have k of x power? Well, here's our definition for k of x. K of x means the same thing as x plus 4. So if I'm raising something to the k of x power, that means I'm raising it to the x plus 4th power. And so what I did really here is I just took my k of x function and I put it inside my f of x function. I'm even going to make these colors match up because I just feel like that would be beneficial, right? So I put k of x into the spot where f of x usually has x. And so that's all I'm doing. I'm shoving one function inside the other. So go ahead and pause the video and see if you can attempt these other 3 here. All right, welcome back. So I'm going to go piece by piece for each one. So I have g of j of x here. Now the function g says take whatever my input is, cube it, and add it back. So I'm going to take j of x and put it in here. Now what is j of x equivalent to? Get that handy dandy highlighter. J of x is the function 2 times x. So this is going to be 2x and 2x. I'm going to cube it and add it here. And that's going to give me 8x cubed plus 2x. The next I want us to do is g of f of x. So the function g says cube it and add it to ourselves. And inside there we're going to put, oops, I messed up my parentheses there. And inside of that we're going to put f of x. And what is f of x? Well, it's that exponential function. So we have e to the x cubed plus e to the x. And that's going to give us e to the 3x plus e to the x. Now let's go ahead and try and find f of g of x. That's going to be our function e raised to the g of x. And that's going to be e to the x cubed plus x. Great. So let's write all of those down, all of those answers in their fully simplified form. So we have f of k of x is equal to e to the x plus 4. We have f of j of x, which is equal to, oh, I didn't do f of j of x. I'm sorry, g of j of x. I was like, why don't I know this one? I have g of j of x, which is equal to 8x cubed plus 2x. I had g of f of x, which was equal to e to the 3x plus e to the x. And I had f of g of x equal to which was e to the x cubed plus x. So there's one thing I really want to point out here at this level. It matters what order I go in. Notice if I make f my inside function and g my outside function, then that's going to give me a different answer than the other way around. Right? This function and this function are not the same. So it matters which way I'm putting my functions together, which one I'm putting inside which other function. All right? And then now I want to introduce function notation if you're not familiar with it. So what we would call this, when I take f of k of x, is we would say this is f compose k of x. So that's the function f compose k. Here we would call this g compose j of x, and here we would call this g compose f of x, and here we would call this f compose g of x. So notice here, like I said before, that g compose f of x is not necessarily, oh, I cannot spell necessarily. Ha! Oh, we're gonna have to try another word there. Woo! Quarantine, getting to her. Is not always the same as f decompose g of x. In fact, the only time those two are the same, it's a very special case, and it'll come up in future math classes. And you can email me if you're curious about it. Okay. So what I want us to do now is to try to go backwards. This is how we put functions together. So now we can compose two functions. But can we decompose a function into two functions? This is really the skill that's going to be most useful with the chain rule. So let's see if we can do this. Let's do an example together. Let's say I had the function y equals the sine of 2x squared plus 4. And I wanted to decompose this into two functions. And I want to find f of x and g of x, so that if I take f of g of x, that I get sine of 2x squared plus 4. And there's actually more than one answer for this. So I'm going to give you my first two thoughts, my first two possibilities here. So I'm going to say that f of x equals sine x, and I'm going to say g of x equals 2x squared plus 4. All right? So now when I take f of g of x, that's going to give me the sine of g of x, which is going to be the sine of 2x squared plus 4. And that's what we wanted. Great. There's another possibility. So here's another possibility. So here's another chance. You could say, I'm going to leave I'm going to say f of x is now equal to the sine of 2x plus 4. And I'm going to say that g of x is now equal to x squared. So if I take f of g of x, that means I'm taking the sine of 2 times g of x plus 4. And that's going to give me the sine of 2x squared plus 4. So those are two possible ways I could decompose this function. I'm going to give you one example that I'd really like you to try on your own and see if you can get. So I want you guys to try this one. You try. Decompose y equals the square root of e to the x plus 1 into a blue f of x and a red g of x so that when I compose these functions together and I take f compose g of x, of course that's going to give me f of g of x, and I want that to equal the square root of e to the x plus 1. So you guys give that a shot and come back after you've spent some brain cells on it. All right, so hopefully you've spent some brain cells on it. Here's my suggestion for what our g of x should be. So if g of x equals e to the x plus 1, and I want f of g of x to be equal to this square root of e to the x plus 1. Oops. This is my g of x, so I want to make this part, the square root part, my f of x. So let's see if that works. We have f of x equals the square root of x, and we have g of x equals e to the x plus 1. So if I take my function f on the outside and I shove g of x on the inside, that gives me the square root of g of x, and that gives me the square root of e to the x plus 1. Oops, plus 1 like that. Plus 1. Yay! So that's one possible answer. And there's more, but that's just the one that came to my mind. Okay. So, what's the big deal with the chain rule then? Why am I caring all about this? The chain rule is going to give us a way to take derivatives when I have two functions composed. So I'm going to state the chain rule, and then we're going to do 3 examples where we first have to decompose the function to take it the correct derivative, and then we're going to do another video that goes more into detail about the chain rule. So here is the chain rule. For a function h of x that is equal to the composition of two functions, f compose g of x, the derivative is equal to f prime with g of x left on its own as the argument times g prime of x. So you often hear this as the derivative of the outside multiplied by the derivative of the inside. So let me restate this in a way that we've been talking about it. So if I have h of x, and that equals f with a g of x inside it, then h prime of x is equal to the derivative of this outside function f prime with g of x inside it, multiplied by the derivative of that inside function, that inside g of x. Let me do a few examples. I think the best way to do these is to try to first decompose the function and understand what's going on, and then take the derivative. So here's my example. So we want to find, given h of x equals the cosine of x squared, we want to find h prime of x. So I would say our first step is to identify the inside function. Then our second step would be to identify the outside function. And then our third step is to apply the chain rule. A pro tip for these is that when you see a trig function like cosine, that's almost always your outside function. That's almost always going to be your outside function. So I'm going to start there, and then I'm going to have my inside function. I'm going to say that that's x squared. So here I'm saying my inside function is g of x equals x squared, and my outside function is f of x equals cosine of x. And so now h prime of x is defined to be the derivative of my outside function, f prime, with g of x as its argument, times the derivative, g prime of x. So I know, hopefully, by now, I have written in my heart what the derivative of cosine is, and that the derivative of cosine is negative sine x. So that's what I'm going to have, negative sine g of x times g prime of x. And what is g of x? That's x squared. So this is going to be negative sine of x squared times g prime of x. So if g of x is equal to x squared, I can use my power rule there and say that the derivative of g prime, is 2x. I hope the colors are helping here. I find this helps me. All right. So then with simplification, this is going to be negative 2x sine of x squared as our derivative. All right. So let's go ahead and try another example. Of the chain rule. Sorry, I lost my place in my notes here, guys. It's just like being in class with me. She lost her place in the notes, and now we have to vamp. All right, let's do another one. So here we have example 2. Suppose h of x equals x to the 4th plus 3, and I raise that all to the 4th power. Now, if you had to, you could expand this and multiply this factor, this binomial, 4 times and get a huge polynomial and take the derivative. Thank goodness you don't have to. The chain rule is going to save us. All right? So first we have to identify our outside function and our inside function. So I'm going to say our outside function, f of x, is x to the 4th. And our inside function, g of x, is x to the 4th plus 3. And I can always check this, right? I could say, look, if I take f of g of x, that gives me something to the 4th power. And if I plug g of x in there, I get x to the 4th plus 3. Okay, great. So my assessment makes sense. So now to find the derivative, h prime of x is going to be equal to the derivative of the outside function with g of x inside it times the derivative of the inside function. So if f of x is equal to x to the 4th power, then my derivative of this will be 4x to the 3rd power. That's my derivative. So this is going to be equals 4 times something to the third power. And what is that something? It's our g of x. Notice here that this g of x is replacing the x in the derivative. It's replacing the value of x. And then, of course, we're going to have to multiply that by g prime of x. And this is our g of x, x to the fourth plus 3. So we're going to use our power rule. So we're going to have here 4 times, and our g of x is x to the fourth plus 3 cubed, and times the derivative of this inside piece here, which will be 4x to the third power. And now I can simplify this. I have 4 times x to the fourth plus 3 cubed times 4x cubed. So I can multiply those like terms and get 16x cubed times x to the fourth plus 3 cubed as my final answer. All right. Now I'm going to show you guys a third example, and it's going to involve a little bit of work. So this one's going to be probably our hairiest example so far. So here we have example 3, where I'm going to say h of x is equal to 1 divided by 3x squared plus 1 quantity squared. I'm then going to use my negative exponent law to say that this is the same thing as 3x squared plus 1 to the negative second power. My outside function here is x to the negative 2. My inside function is 3x squared plus 1. So when I take my derivative, h prime of x, I'm going to have f prime of g of x times g prime of x. So this is going to give me negative 2 times my variable to the negative third power. Inside here I'll have g of x and g prime of x. So then that's going to give me negative 2 times 3x squared plus 1 times, oops, I almost forgot my negative third power. Yikes. To the negative third power times the derivative of my inside function, which will be 6x. I have to clean this up, and I have quite a lot of simplifying to do. So again, I'm going to use my negative exponent law here. So this is going to be negative 2 times 1 over 3x squared plus 1 to the negative third power times 6x. And that's going to give me negative 12x. Oops, when we moved that to the denominator, we took care of the negative. Sorry, gang. Negative 12x divided by 3x squared plus 1 cubed. All right, so those are my 3 examples. I will see you in the next video for more discussion of the chain rule and more examples. You might need to watch this video a couple times and read the section. The chain rule takes a lot of practice to fully get. So practice, breathe.